Aloha everybody, this is Gigi from Kauai Community College. In this video, we are talking about strategies for division in base 10. So division is to find the missing factor in the associated multiplication problem. What does that mean? If you have 56 divided by 8, whatever that answer is, that blank, 56 divided by 8 is blank, if and only if 8 times blank is 56. So you are looking for this missing factor. Okay, that's what it means to be looking for the missing factor. Okay, so we all know that's maybe not all of us, but some of us know. However, if you know your multiplication fact, you know that that question mark is 7. Therefore, 8 times 7 is 56. Therefore, 56 divided by 8 is 7. Okay, here is some terminology to know. Just kind of like when you are doing addition, the sum is the answer to an addition problem, and then the difference is the answer to a subtraction problem, and then the product is the answer to a multiplication problem. Now we have a quotient. A quotient is the answer to a division problem, and if your division problem is left with something that is less than the divisor, the thing that you're dividing it by, then we call that a remainder. Okay, so hopefully your problems are nice, meaning it has no remainder. But if you are left with something in the end, with something that is less than the divisor, then your answer will have a remainder. But again, the answer to a division problem is called the quotient. So 7 is the quotient of 56 divided by 8. So models for division is kind of confusing of like, how do you know you are dividing, right? Again, I'm going to explain to you how you know. And you know because by the definition, you are looking for the missing factor, right? So division can be seen in two different scenarios. One is called partitive model, and the other one is the quotative model. And I'm going to go ahead and explain to you what the difference is between the two of them. So if you have 100 chocolate covered macadamia nuts and it's being put into 4 boxes, how many go into each box? So the model will look something like this. You have 100 total. You have 4 equal parts. How many go into each? Okay. Now, what's the other model? You still have 100 chocolate macadamia nuts, but now it is being put in tiny little bags. And we know that 4 goes in each bag. So those little question mark right there in the partitive model, we know that. We know 4 go into each. The question is, how many bags, meaning how many equal parts are there? So the model will look something like this. Again, you have 100 macadamia nuts, 4 go into each. How many go in? How many bags do you have, right? Okay, so that's the quotative model versus partitive model. In either case, what you are looking for is 4 times what will get me to 100, right? So when we have a missing factor, that is called for a division problem. Therefore, it find the division problem of 100 divided by 4. And this is what I mean by division is being defined by looking for the missing factor. Here you're looking for that missing factor, 25. If you really have to know the answer, 25 is the answer. You're looking for the missing factor. Therefore, it is a division problem. 100 divided by 4 is 25. Okay. Now, we're not talking about the answer. We're talking about what division means as an operation, right? Looking for the missing factor. That's what we're doing. So, some strategies, but before we talk about strategies, let's talk about the properties. Now, since division is defined based on multiplication, does it inherit all of the properties that that multiplication problem has? The commutative property is 10 divided by 5 the same as 5 divided by 10? Well, 10 divided by 5 we know is 2, right? So because 5 times 2 is 10. Okay? 5 divided by 10 is blank if 10 times blank is 5. Well, what goes in that blank? A half. A half of 10 is 5. So are these two the same? And the answer is no, they are not the same. So the commutative property for division does not hold, right? Now, if you cannot commute, do you think you can associate? Meaning this, if you have two division sign like that, can you go this and then that? Are those the same? My division sign looks funny. There you go. Are these two the same? And the answer is no, because this one right here, 10 divided by 5 is 2, and then 2 divided by 2 is 1. What is this here? 5 divided by 2 is actually 2.5. And then 10 divided by 2.5. If we know fraction, we would say that is the same as 10 times 2 over 5, and that is 4. The answer, you're going to have to trust me on that. If you don't know fractions yet, the answer are not the same. So the associative property doesn't work. I mean, honestly, you already know, right? If the commutative property doesn't work, does the associative property really going to work? What about a distributive property? Like this. So commutative property doesn't work. Associative property doesn't work. Distributive property, it has some addition in there. 5 plus 2. Okay, is that the same as 10 divided by 5 plus 10 divided by 2? Does that distributive property work? Now, if you think about it, 10 divided by 5 is 2, plus 10 divided by 2 is 5. So this answer right here is 7. Well, this here, 10 divided by this is 5 plus 2 is 7. 10 divided by 7 is 10/7. Obviously, they are not the same. So the distributive property does not work either. All right? That's too bad. None of these properties work for division. And you should expect that, right? Because when we were talking about subtraction, and I asked you, is there any order property going to apply to subtraction? And the answer is no. You couldn't reverse the order in subtraction. So you should not expect division to have the same, right? Okay. Strategies. Let's think about 396 divided by 12. Well, whatever that answer is, 12 times that will be 396. So if we think about the area model for multiplication, because this right here is a multiplication problem. So if you think about 12, right, we're saying 12 times what? And this is why I say this is an open area model. We leave it open because we don't know what goes up here. Okay, that's what we're trying to figure out. What goes there? Well, 12 times what will give me 396? I don't know. Can I try 10? Because that's something that I know, right? 12 times 10? 12 times 10 is 120. So I have used 396. I have 396. I have used 120. So I have 267 left. Okay. Now I'm going to learn from what I had just done. 10 times 12 is 120. So if I double that, I get 240. So I'm looking at 20 right here. 12 times 20 is 240, right? I currently have 276. I use 240 left. Therefore, I have 36 left. There's 36 to go right there. So 12 times what? Give me 36. I say 12 times 3 because that gave me 36. And then so 36 minus 36 is all done. So I have used up everything. So to answer this question, what goes on the top of my rectangle? This question mark is 10 plus 20 plus 3. And that is 33. That is 33. Therefore, 12 times 33 is 396. Therefore, 396 divided by 12 is 33. That's the open area model. We leave it open because we don't know when it ends, and we're just trying to go until we cannot have any left. And that is the open area model. Okay, now that is sort of a little visual. Is very nice to like really get students to develop their thinking. And then once they have a process or something to hold on to, we want to practice their number sense. Okay, what does that mean? Let's do some number talk, do some mental strategies, right? For example, if we have 84 divided by 7, well, I know that friendly numbers of 7 is 70, and 84 must be 70 plus 14. 70 divided by 7 is 10. 14 divided by 7 is 2. Therefore, 84 divided by 7 is 12. And that is it. That's the mental strategy. Okay, of breaking the numbers into nice parts to divide. Okay, Now here, 396 divided by 12. When looking at 396 and 12, I'm seeing 3 everywhere. Meaning 3 goes into 396 and then 3 also goes into 12. So this is called proportional thinking. Okay, so 396 is to 12 is the same as, if I divide both by 3, I have the same as what is to 4? 132 is to 4. Now I can keep thinking, well, you know what? That is like, if I reduce that by like 2 like this, right? It would be what? 60 divided by 2. I would have 66, right? And then 66 divided by 2 is the same as 33 is to 1. Okay, that's what we call proportional thinking, and that's how we get your 33. Now, I avoided writing the fraction, but maybe it make more sense if I have written that in a fraction, right? So I would say 396 over 12 is the same as 132 over 4 is the same as 66 over 2 and is the same as 33 is to 1. Therefore, the answer is 33. And that is why we call that proportional thinking. It's a little bit more advanced, but if students have number sense, perhaps they would be able to think that. Okay? So those are 2 mental math strategies in division that we could that I could think of at this point. Now, partial quotient method is one that really stands out. It really is a great way to replace the old-fashioned method. Okay, the long division, that's like students are very is really dreadful. Students do not like it because they have to get the exact answer when they're doing the long division method. Partial quotient is really practicing number sense and estimation. Okay, so let's go ahead and think about that for just a second. Okay, so 576 divided by 6 is blank because blank times 6 is going to get me 576, right? So now this is what I mean by number sense and estimation. I know that 6 times 100 is 600. 576 is close to 600. So my answer is pretty close to 100, but it's below 100. Okay, perhaps it's like 90 something. Okay, that's the number sense and estimation that we want students to begin with before they even put their nose into the problem, right? And start writing stuff down. Have them think about an estimation of what the answer would be. Okay, now I'm thinking then 6 times what will get me to 576? That's the question, because division is to look for the missing factor. So I'm going to go 6 times what? I don't know. It's not 100. So let's try 50, because I know 5 times 6 is 30. So 50 times 6 is going to be 300. That's a nice fact to know, right? So I'm just going to use that. And this is why partial quotient is nice, because students can use what they know, whatever facts that come to mind. As long as it's not over, they can use it. So subtract, I have 276. Okay, now I can't have another 50 because that would be another 300 and I don't have enough. So I'm going to go ahead and go for 20. Okay, now in your head, you might go, well, why did you go 20? Why couldn't you go bigger? Well, you could, but that's what comes into my mind right now at this point. And this is what I mean by by that number sense and flexibility, right? Just let the students try it. They don't have to get to the exact answer yet, and because they keep subtracting until it's done. And this is how partial quotient really kind of relates to the open number line method, right? Okay, so 6 times 2 I know is 12, so 6 times 20 would be 1210 or 120. Subtract, I have 150. Oh, look at that. I have 120 more in there. So I'm going to do 20 more. And so I'm going to have to subtract 120. 36 left. And for some reason, I couldn't think. It must be 6, right? Because 6 times 5 is 30. So 6 times 6 must be 36. So then I am subtracting 36 and all done. Right? So to think about that missing factor, 6 multiplied by 50 plus 20 plus 20 plus 6. And that would be 6 times 96. 6 times 96 is 576. That's the missing factor. So by the virtue of that multiplication problem, we say the answer is to the quotient is 96. Okay, so partial quotient really allows flexibility. I would prefer that when you are teaching, try partial quotient before you do that long division. Now, students might automatically know long division because they know their multiplication facts. That is perfectly fine, right? The long division process basically is just partial quotient, but just less steps. Okay, so that is partial quotient and why it's helpful for division. Does it work with bigger numbers? How does it work with bigger numbers? Okay, so let's go ahead and take a look. 9,345 divided by 35. Again, we're looking at 35 times what will give me 9,345. Well, 35 times 100 is 3,500. 35 then times 200 must be double at 3,500, so that must be 7,000. If I have another copy of 3,500, I would go over 9,000. All right, so the answer must be less than 300. That's what I'm thinking. It's 200 something, more than 200, but less than 300. Okay, so I am thinking 35 times what? I just said my answer is more than 200, but less than 300. So I'm just going to say, okay, let's go and take a look at 35 times 200, right? 35 and 35, my double facts tells me that it's 70. Therefore, 35 times 200 must be 7,000, and 7,000 really is 7,000. I'm going to go ahead and subtract. I have 2,300, so I do not have another 100 more. I have less, so what do I go? I'm going to go with 40. Now, I'm going to tell you how I think of that 40. 35 and another 35 is 70. Okay, so 35 times 4 must be twice as much as 70, and that's 140. So 35 times 40 must be 1400. And I'm going to subtract. Okay, I have that left. Okay, now remember that 70. How am I going to use that to get to 945? I'm thinking 700. 35 times 20, right? 35 times 2 is 70. 35 times 210 is 7010, which is 700. And I'm going to subtract. I have 245. Then I am going to try 6. How did I go up to 6? Okay, so this right here is 70. 70 times 3 is 210, right? So 6 is really 3 doubles. And double 35 is 70, so 3 of those must be 210. So 35 times 6 is 210. I'm going to subtract, and I have 35 left. So therefore, 35 times 1 is 35, and I am all done. Therefore, 35 times all of that is 9,345, and all of that is 267. That is the missing factor. And when I see the missing factor, I am saying that's the answer to the division problem. Therefore, by the virtue of that multiplication problem, 9,345 divided by 35 is 267. And that is that for division.